In this part of geometry and measurement, we're going to look at geometric reasoning. We are going to use inductive and deductive reasoning to determine whether geometric statements are valid. Remember, inductive reasoning involves just checking a few examples in order to determine if a statement is true or false, where deductive reasoning looks at proof or mathematical definitions. Also remember that just by checking a few examples doesn't guarantee that our statement is always true or valid. We can look at relationships and reason through Venn diagrams. In the figure below, we have a Venn diagram representing triangles. We have right triangles, which have 90-degree angles, equilateral triangles, which has 3 congruent sides, and 3 60-degree angles. Scalene triangles, if you recall, have 3 unequal sides. Therefore, we can look at some valid statements. Since equilateral triangles have 3 congruent sides and scalene have 3 unequal sides, then no equilateral triangle can be scalene. Also, no right triangle is equilateral because an equilateral triangle has 60-degree angles and not a 90-degree angle. If we look at the intersection of our Venn diagram, we can see that some right triangles are scalene, having 3 unequal sides, but some right triangles could be isosceles, having 2 congruent sides exactly. Remember that our hypotenuse has to be our longest side. Therefore, some right triangles are scalene, and some scalene triangles can be right, but not all scalene triangles are right. For example, we can draw this obtuse triangle, seeing that some scalene triangles cannot be right. We can do the same thing for quadrilaterals. We know that parallelograms have opposite sides being parallel and congruent. Some parallelograms are rhombuses, and rhombuses have opposite sides being parallel and 4 equal sides. Some parallelograms are rectangles. Rectangles are parallelograms that have opposite sides being parallel and congruent and 4 90-degree angles. And some parallelograms are squares that have 4 congruent sides and 4 90-degree angles. From this Venn diagram, we can see that all squares by definition are rectangles. All squares are rhombuses, but only some rectangles are squares, and some rhombuses are squares. Parallelograms are sometimes rhombuses, sometimes squares, and sometimes rectangles. Trapezoid, by definition, have exactly 2 parallel sides. Therefore, no trapezoid can be a parallelogram. We also look at if-then statements in geometry, where the first part of our statement is the hypotenuse, and the second part is our conclusion. Therefore, if we look at the statement, if a quadrilateral is a square, then it must be a rectangle. If I draw my square, I will notice that by definition, all squares are considered rectangles since opposite sides are parallel and congruent and there's 4 90-degree angles. So by definition, this statement is always true. On the PPST, we're going to be asked to find counterexamples to disprove statements. Remember, a counterexample is just one example that shows that a statement is false. So in our hypothesis, if a triangle is a right triangle, we want to disprove that it must be a scalene triangle. So if we look at these examples, the first thing we want to hold true is we're looking only at right triangles, eliminating 2 of our possibilities. To show that it's false, we would look at, well, here's a right triangle that has 2 congruent sides, therefore it shows a counterexample. Recall, a counterexample is an example that shows a geometric statement to be false. If a quadrilateral is a rectangle, then it is a square. This statement is not always true because I can draw a rectangle that does not look like a square, showing that this statement is false.